Okay, welcome. We're going to talk about reflection. This is coming after our translation where we were working with a slide. Now we're working with more of a flip. And if you flip, you have to flip over something. So we're going to be looking for our line of reflection as we go through this. So let's go with our 3x3 that we were working with, or 3x5. Let's put it up here now. Again, we work with the rectangle 1, 2, 3, 4, 5. We work with the rectangle because it helps us kind of see, because if we were working with a square, I think we would lose some of the idea of the shape moving because the shape reflected looks the same. We always want to work with letters because they're going to start with a letter. This way we can identify which coordinates are moving where. So let's just look at one example where they say over y-axis, and then they'll want you to do a flip over x-axis. And the order of this is very important. You have to do this first. And basically what we're doing here, or what I like to do, is tell my students to just kind of, here's your line of reflection, here's your y-axis, this is your line of reflection. Letter B is 2 to the left, so to flip that, I'm going to go 2 to the right. And here's my letter B. Same thing with C, 2 to the left, 2 to the right. And then look at the letter D here, which is 1, 2, 3, 4, 5, 6, 7. So we're going to go 7 this way, and the same thing with A. And what you notice, and what's important and different from the slide, is that when we did our slide, the B actually slid to here, but in this case, actually the A is going to flip over to this side. The A was 7, I shouldn't use that color, is about 7 units this way. So now I want the A to be 7 units this way. And again, I'm using this y-axis as my LOR, line of reflection. Now moving forward, let's look at my x-axis being my line of reflection here. So now this is my LOR, my line of reflection. And it's the same premise. You know, my letter D is about 4 units above the x-axis, so I want to go about 4 units below. And same thing with A. A is about 7 up, so I want to go about 7 down. And then I can recreate my shape, understanding that my B is up here. It's 7 units from my x-axis, so I want it to be 7 units here. My B will go here, and A will go here. My letters flip. There's an actual reflection there. The flipping happens where the shape goes from being A, B, C, D to a flip happening where it's A, C, B, D. So the flip is happening with the letters. So meaning if this rectangle had an arrow in it and I flipped it, the arrow would now be facing down. Or if I had an arrow facing this way in this picture, when I reflected it, the arrow would now be facing this way. Now another example of a reflection is, let's use my 3x5. Is where they'll actually give you, and of course I need my letters, they'll actually give you a line of reflection. So let's look at our LORs here as X or Y being equal to something. So they'll say line of reflection at, X is equal to 3, and then let's do a line of reflection at y is equal to -3. We'll use same number, but one positive, one negative. What that means is that we're going to go where x is 3, right here, and we're going to draw a line vertical, and create our line of reflection, meaning that everywhere on this line, x is equal to 3. For instance, my coordinate here is 3, 9. My x-coordinate is still 3. That's why that's the line of reflection for x. Which means I'm going, I like that orange color today, a little Halloween. 1, 2, 3, 4, 5 to the left. The difference between 3 and -2 is 5. You can look at that. And then I'm going to go 5 this way. And then this now becomes my C. And I could count, of course, all points. Or I could just create my 1, 2, 3, 4, 5, my 3 by 5. Knowing that my letter D will flip to the outside, my B will stay more so on the inside, and my letters are going to flip here, and here's my new shape. Again, if my arrow was facing this way, it is now facing this way. If you look, my arrow faces the A and the letter D, and here faces A and the letter D. And then let me draw my y-axis where y is equal to 3. Here, y is equal to -3. At any point on this line, even if I plot a point right here, it would be -9, -3. That's what makes that a y is equal to -3 line. And the same idea happens where my letter C is 1, 2, 3, 4, 5. Not from the mistake a lot of students make is they count from the x-axis. Make sure you're counting spaces to your line of reflection. 1, 2, 3, 4, 5. So I'm going to go down 1, 2, 3, 4, 5. And then recreate my 3 by 5. In which my letters flip B, C, D, and A. And what will be asked of you guys is, for instance, taking the letter A, which was originally -7 and 5, and then they'll ask for, after the 1, 2 reflections, what is your new coordinate for A, which would now be 13 and -11. Now there is a process in which you could do this without graphing, but that's not what we're going to focus on today. Today we just want to focus on how we use our geometric tools, our graph, our reflection principles, and how we could get a shape to reflect two separate times and come up with a coordinate for that new vertices, as we call it.